day everyone. Today is another class or another presentation of physics. This presentation is for grade 10. In this presentation we will cover some questions of your textbook. We're trying to give answer actually is there in your textbook, but what we are going to do is to explain the answers of all those questions. So first we will start with the question 1. So start with question 1. Question was, as we could say here, it's about a shock from a meter handrail. So have you ever got a shock from a meter handrail? Actually it's not that way. You are not getting shock from handrail, but it's the way around. You give a shock to handrail. So have you ever got shock from a metal handrail? Explain why it was really the other way round. Actually, you give shock to handrail, not handrail to you, but you to handrail. How? As we know that you are your body or yourself is very good insulator, so you will have rubbed electrons either into yourself or off from yourself. So electrons are rubbed into yourself or off of yourself. Then perhaps by sliding your feet over a carpet, maybe, so we get some electrons into or off from yourself. So the metal handrail is a conductor, a very good conductor. So you are insulator, and this metal or handrail is a good conductor. So when you touch it, when trying to touch it, it's not actually for handrail, only for handrail. It could be for your car, it could be from the door as well. So when you touch it, it allows the electrons to move where to restore the balance, and this is what you feel as a shock. So electrons is just moving to balance, to restore what the balance of the charge. So then you will feel like what a shock. It comes from handrail, it comes from your car, it comes from sometimes the door, many things. So that's why we have said here it is really the other way around. You are not giving a shock to the shock is not coming from handrail, it comes from where? From your body or yourself. Okay, now we'll move to question number 2. We have an ion. That ion has, or that atom has 5 protons. It has 5 protons and 6 electrons. So is it positively or negatively charged? So what's the charge of this ion or this atom? Is it positive or negative? As we discussed in last presentation or the presentation before, we said it depends on what? Depends on the number of electrons and the number of what? Of proton. So if electrons is greater than proton, so that ion is negatively charged. So we have how many electrons here? Is 6, and proton is 5. We have 6 electrons and 5 proton. So 6 is greater than 5, so the charge is what? Negative. We just use this figure to explain the result of this one. So if we put like here 2, 4, if we add 2 here, this one and this another one here, so we have how many electrons? 1, 2, 3, 4, 5, 6 are moving where? Around what? The protons. Electrons are negative, protons are positive, neutrons are balanced, no charge on proton. So we have 6 and 5 what? 5 proton. So the charge is negative. Same in part 3. In part 3 or question number 3, we have an ion has 7 protons. So protons equal to 7 and 4 electrons. So we have 4 electrons here. If we put more 2 here, 1, 2. So we have 1, 2, 3, 4, 5 electrons, and we have 7 protons. 7. So electrons is what? Less than the number of proton. When the number of electrons, which equal to 4, is less than the number of proton, which equal to 7, so the charge is what? Is positive. The charge is positive. Question number 4. So in question number 4, we have, as we can see here, a storm. Storm clouds can become charged, leading to lighting. Any clouds can be charged or become charged, leading to lighting. So suggest how cloud can become charged. How cloud can become charged. The key idea here is what? Is friction. The key idea of charging any clouds, it comes from friction. How the friction affected? So when water droplets rubbing against each other, as we can see here, the drops of or the droplets rubbing against each other, it could be also for bits or dust or anything else. So although water is a conductor, water is a very good conductor. It's very good. So in cloud, it's insulated. In a cloud is insulated from what? The ground. As we can see here, the cloud is insulated from the ground. So when the ground, so the charge can build up. Why? Why it's built up? Because no connection between this one and the ground. So when the water drops rubbing against each other, they will move. Say this is the positive charge and the ground is positive, because the ground is positive charge. So the positive one will be repel, or there a repulsion here between the ground and the positive one. So they are moving up, and the negative charge they will move down. So the water it comes where? Down, comes down to the ground. So that's why. So the key idea of this one, how cloud can become charged, it can become charged because what? Of friction. And the cloud itself is isolated from what? The ground. It's isolated from the ground, so there will be a charge on it. Okay, now see what's happening here. The positive one are repel from the ground, and the minus one are comes down. So the water it comes where? To the ground. Yep. A question. So this question number 1 on other topic. This question said the key discovery at the end of 19th century was the electron itself. So it was about electron. So the question said from your knowledge of atoms, explain why it's negatively charged charges or negative charges that move to create electrostatic effect. So as we know from the last few slides or last few presentation, electrons are extremely small. It's very small compared with other parts of any atom, and negatively charged, so it's small and negative. Also electrons, it moving around where? Around the outside of atoms. So both of them, or for those reasons, because they are extremely small and negative, are also electrons are moving or also around the outside of atoms. So for those case idea, it make it much easier for electrons to be moved about. So it's comparing or than the positive charge part of the atom to account for all electric effects we know. So because the key idea of this one, why electrons is the discovered at the end of 19th century. So was what electron? Why? Because it's what electrons are extremely small, and because it's negatively charged, and because electrons are also around the outside of atoms. So these key idea or ideas make it much easier for electrons to be moved about. Okay, for next question now. This question describe how electrostatic effect, the effect of electrostatic stop you, it could or can use or has the power to stop you from falling through the floor. How? Why? That's because the electron clouds in your feet repel what? There is a repulsion force here between your feet and what? And the floor, and between your feet and the electron clouds in what? The floor. So the force of repulsion here is easily enough. It's enough to stop you falling through. So because what? The reason of that one is because what? The force of repulsion. That's happened between where? Between the floor and your feet. Next. So question number 3, part A. Complete the diagrams to show what happens when a cloud is rubbed on a material that gains electrons, this first part, and when cloud is rubbed on a material that loses what? Electrons. So we have two types of clouds here. One of them gains electrons, and another one what? Loses and electrons. Two types of what? Clouds here, or material here, rubbed on a material. This one we have clouds here, this one and this one, and we have two types of what? Material. One of them gains electrons. This one, for example, gains electron, and when rubbed on a material that what? Loses electron. For example, this one. For polyethylene here, for polyethylene rod here, or for first diagram here, should be negatively charged, and this one should be negatively charged, and this one what? Positive charge. This one is positive charge. Why? Because this one gains electrons. This one it gains electrons. So the charge here will be electron, because the electron is negative. So this one, first one should be negative or must be negative charged, and close what? Positively charged. The opposite is here in this rod here, because it loses electrons. So electrons are moving from this one to what? To the clouds here. So this one is minus, and this one what? It will be positive charge, must be positive charge. This one is positive, positive, positive. This one is minus. So the second one should be positively charged, and the cloud already negatively charged, because the charged or the positive one, it comes to what, to that or to this material, because we have two types here of material. One material gains electrons, another one what loses electron. P, or part B of the same question, what can you say about the sizes of the positive, negative charges on the cloth and the rod, and on the rod in each of the diagrams here? So what's about the size of what the charge here and here, and what about the charge here and here? So the charge here, they will be equal, they must be equal, and what, opposite. So that the number of charges here, for example 10, so here it will be 10. Here is positive, here is minus. Here 10, 10, minus, positive, positive, minus. So they will be equal and what, opposite, different in charge, positive, negative, or negative, positive. But the amount or the quantity, they will be equal. Now we will move to another topic, which is a current. So the current, what's the current? We will go through the definition of a current and how we can measure the current. So now we already know that because there is an electrons are moving from part to part, or there is charge making electrons moving, so there is a current moving from part to another part. So what's the current? If we have any conductor and there is no current here, if we have or when there is no current in a conductor, the free electrons move randomly between what, atoms. They are moving where, randomly between atoms with no overall movement. Okay, this first part. The second one, when you connect it in electrical circuit with a power source, for example like a battery, so what happened here? There is a current in the conductor, so there is a current moving or flowing, start flowing from minus part to the positive part, from the minus part to the positive part, as we will say from next slides. So when we connect it to electrical circuit, so there and this circuit contains a source of power, or like a battery, or power source like a battery, so there's a current in conductor. Now electrons drift in one direction, and this direction must be from minus to positive, minus to positive. We will see that one later. So while still moving a random way as well, and still moving where, random way as well. So the drift speed very slow. Why? We will say that later. So the speed here is very slow, often only a few millimeters each second. It could be millimeters per second. So there can only be a current in a conductor when it's connected in a complete circuit. So a current in conductor, or when the circuit is broken, so the current is stopped. So to make the current moving, we need to connect it what, in a circuit. Circuit have what, a source of power, and then we will say the current start moving from one point to another point. This point, they can start moving. If we have a battery, we'll start from the minus part to the positive part. And when the current or the circuit is broken somewhere in the circuit, so the current will what, stop. Uh, the size of an electrical circuit, any electrical current, the size of an electric current depends on what the number of electrons that are moving and how fast they are moving. So because the size is different, so instead of measuring the actual number of electrons, we use what total charge carried by electrons around the circuit each second. So current is what flow of what of a charge. Definitely it's flow of what of a charge. This charge, it depends on what, as we said, the number of what electrons and how fast they are moving. So electric current is measured in what? Amperes. In amperes. Or can write it in shortcut like this: AMPS, ampere. For the next one here, slide here. So when you are going to measure any electric or the current in electrical circuit, we use what? We use a device, small device. It's called what? Ammeter. It's a meter. So we use an ammeter, this one an ammeter, this here or here, they are same, to measure what current in electrical circuit. So when current is very small, we couldn't use what? Ammeter. We need to measure by another device. It's called what? Millimeter or milliammeter, which measure current in what? Milliamperes. It's not ampere now. It will be with milliamperes. For example, 0.0001 ampere. Even small currents are measured with what? Microammeter. So we have three different measurement type or measurement device. It could be by ammeter for the what do you call big value. For middle one, we could use milliammeter, and for the small one, we will use microammeter. So the ammeter is connected in a circuit in such a way here in those circuits, two circuits here. So this is the battery, this is the source of power, this ammeter to measure the current here, and this one is for example lamp or resistance or anything here. So when the current is moving from where, as we said, from minus to positive. So this is the way of what? Of current. This is the direction of what? Of I. This is I. So current are start moving from here, from this battery, all the way here, and then comes to here, and then here, and then until here. So if you put a meter here, or put it here, or put it here, or put it here, or here, or any place here, so the current will be same. They will give the same result. Why? Because the circuit is connected in what? In serial connection. As we can say here, this is the minus, this is the source, it could be battery, this is minus, this is positive. So current start from this part here and moving here like this. So this is what I. So if we put a meter, this one is positive, this part is positive, so we need to connect the positive part here, and this one what is minus. The other part here is with the minus part. This one with the positive, and this one with minus 1. So if we put a meter here, we put it here, anywhere on the circuit, so we give the same result. Okay. As we said before in the last slide, so when you are going to, or when you want to measure the current in particular component, such as for example lamp, motor, resistance, anything, so the ammeter must be connected in what? In series. Must be connected in series with those components. like in this circuit here. So this is the power supply, or the power source of the power, is connected with what? Two different things here. Different things here. For example, resistance. It could be resistance here. Okay. So in series circuit, as this circuit here is connected in series circuit. In series circuit, the current is the same at all points. So it doesn't matter where the meter is put. You can put it here in position 1, A1, or in position 2, or in position 3. It will give the same result. So A1 is equal to A2 is equal to A3. But this is not the case in when parallel circuit or with parallel circuit. As we can see here in this figure, this is this connection is in parallel. We have two resistance here and the power source of power here. So current will start from minus and moving where to positive. So current, it comes from this part all the way until where? Until this point here. So when the current is arrived here, will be what happened here. If we say this one is a total, or the total current here, so current will be divided in this point. Some of current, it comes from this side, and the rest will come from where? This side. So the amount of current here, A1 or A2, it depends on what? Depends on the value of R1 and R2. So we have some value here and another, the rest is it comes from where? This part. When we add them together, A1 plus A2, it will give what? A total. So a meter couldn't be put in any place here. No, it must be in some specific places, depend on how the circuit is connected. As we can see, there is another thing here is called voltmeter. This is a voltmeter. It's used to measure what? The value of voltage. We will discuss these things later. So now we have what? A circuit. We have a current moving through it. So we can measure this current by a meter, by millimeter, by micrometer or microammeter. There are two different types of this one. So just we need to mention that current in wires of circuit is what is flow of what? Electrons around the circuit. It must note that what? It's moving from negative to positive, not the opposite. It's always moving from negative to positive. The small line here is describing the negative part, and the big line here is describing what? The positive part. So always current comes from minus to positive. Here the slide, what happened here? The electric current, or the electric current is what? It's amount of what? As we said before, of a charge. This amount of a charge flowing where? Every second. It's moving every second. So the number of columns per second. The number of columns per second. So the equation of it is what? I is equal Q over T. I is what? Current in ampere. It measured by ampere, milliampere, or microampere. And the Q is what? It's a charge in what? In coulombs. It is what? C. So T is what? Time in second. So we can use this triangle to calculate any one of them. If we're gonna calculate I, so I is the Q over T. If we would like to calculate T is equal to Q over I, if you are going to calculate Q is I times T. I times T. So the crank is what? Is amount. The current is amount of what? Of a charge. Amount of charge. So this is all for today. Next class we will continue on the same topic, which is the current. We will see different types of circuits and how the current are moving through them. Thanks for listening and see you next week. Thanks.